Welcome to the video for valuation of bonds and shares. In this video, we'll look at some fundamentals of bonds with maturity. Now, typically, bonds have a known interest rate and a maturity period. Now, how do you find out the value of this bond? So, as a general rule, the value of any financial asset, such as stocks, bonds, or even physical assets like buildings, machinery, etc., is simply the present value of the cash flows that the asset is expected to produce. So, value is the present value of cash flows. Now, typically, a bond with defined maturity period provides interest payments during the life of the bond plus the amount borrowed, that is the maturity value of the bond, when the bond matures. So the typical cash flow for a bond with a 5-year maturity period will look something like this on the time scale. So we have 0, 1, 2, 3, 4, and 5. At the end of each of the 5 years, we'll get interest. So INT represents the interest. Also, at the end of the 5th year, in addition to the interest, we'll get the maturity value. Let's say it is represented by M. And this point here is the bonds value. So this bonds value will be nothing but the present value of all of these cash flows. But in order to find out the present value of the cash flows, we need to discount these cash flows at a rate. So what should be that rate or that discount rate? So the discount rate should be the rate at which the other bonds with similar characteristics are available in the market. So basically, if you did not invest the money in the bond and you invested money in either some other bonds or some other instruments, what is the interest rate? That is the interest rate that you should use as the discount rate. It can also be the rate of return that you would expect to get, or in other words, the required rate of return. So let's say we represent that as KD. So basically, if you purchase a bond which is giving a coupon rate of 10%, however, the other bonds in the market are giving a coupon rate of 8%, then you will discount your bond at 8% to find its present value. Now, why would you need to find the present value of a bond? So, if you find out the present value of the bond, you can compare it with the market value at which it is being offered to you, and then you can decide whether you want to buy it or not, depending on your analysis as to whether the bond is overvalued or undervalued. So basically here we have to find the present value of all of these cash flows now here we'll have for the 5th year interest and then the maturity value. Let's say this is PV1, PV2, PV3, PV4, PV5, PV6. And let's say the bonds value is represented as B0. So B0 will be equal to PV1 plus PV2 plus PV3 and so on up to PVN minus 1 plus PVN. So basically in this example these two combined will be PVN and PV4 will be PVN minus 1. Now we know that for compound interest A is equal to P into 1 plus I to the power n. A is the amount that we are going to receive at the end of the tenure. P is the amount which is being invested at the beginning of the tenure. I is the interest rate per compounding period and n is the number of compounding periods. So this can also be written as future value is equal to present value into 1 plus kd to the power n. Now in our case the future value, let's say in case of PV1, is the interest and the present value is PV1. So INT is equal to PV1 into 1 plus KD to the power N1. So this is equal to PV1 is INT divided by 1 plus KD to the power N1. Now here we are assuming that all the interests are of the same amount. So PV2 will be INT divided by 1 plus KD to the power N2 plus INT divided by 1 plus KD to the power N3 and so on, plus for PVN minus 1 it will be INT divided by 1 plus KD to the power N minus 1 plus INT divided by, now for PVN we'll have two parts, interest and the maturity value. So let's take care of the interest first. So INT divided by 1 plus KD to the power N plus for M divided by 1 plus KD to the power N. Both will have the same tenure for discounting. So we can have this part in one bracket. Let me erase this portion here to continue this discussion. Now this part can be written as B0 is equal to INT divided by 1 plus KD to the power T and sum where T is equal to 1 to N. So here we have INT divided by 1 plus KD to the power 1 plus INT divided by 1 plus KD to the power 2 and so on. So it can be written as this plus now this portion which can be written as it is. So M divided by 1 plus KD to the power N. So this is the formula to find out the present value of a bond, where INT is the amount of interest, M is the maturity value of the bond, and KD is the discount rate. Now, if the interest is the same, then this represents an annuity. So we can also use the present value of an annuity for this portion, and then present value of a lump sum for this portion, that is the maturity value. So that is another way. So basically, we can also write this formula as INT sigma t is equal to 1 to n 1 divided by 1 plus kd to the power t plus m into 1 divided by 1 plus kd to the power n. So this portion can be written as the present value of an annuity factor, and this portion can be written as the present value of a lump sum. So we can also write this formula as INT into present value factor of an annuity, where interest rate is KD and the tenure is N, plus M into present value factor of a lump sum, where interest rate is KD and the tenure is N years. Now we can also use the financial calculator to find out the value of a bond. We will see how that can be done with the help of an example in the subsequent videos.